Hey, Directrix here. Another great math video for you. Here we're graphing parabolas. This time we are going to do it where we have the center at HK. Okay, now I do a little differently than some people. So what I tend to do is I look at the focal point and the directrix are the absolute value of P distance from the vertex at, I go negative h and negative k. And the reason I do that is just to remind us to take the opposite sign of what is in the parentheses. Okay, so let's look at what that is. Again, we have in standard form, here's our general form if we were at the center or the origin at 0, 0. Now all of a sudden we decide to move it. We want to shift that parabola around the graph. So what we do is we have x minus h squared, right, because the x is being squared, equals 4p y minus k. Now you notice there's no square here. So x minus h squared. In this format, then what we would get is a parabola. If p is greater than 0, again, the parabola will be facing up. If p is less than 0, the parabola will be facing down. And if we have the other form where it's y squared equals 4px, then we would get y minus k squared. Okay, the k still stays with the y, right? Equals 4px minus h, not squared. The center or the vertex, again, is still at hk. H is always associated with x. K is also associated with y. We take the opposite signs of those values to get our vertex. And that's where the negative hk comes from. All right, so let's look at an example here. Example number 1. We can see that we've got x minus 3 squared is equal to 8, y minus 1. So first things we have to do is diagnose, like what's going on, right? So we see that the x is squared. So we're going to be opening up in the up position like this, or maybe in the down position. Next thing we have to do is we have to look at this number here. Is it positive or negative? Well, we notice it's positive, so we're going to be pointing up, right? Just as we stated before, that p value is going to be positive. Our vertex, or our center here, will be at the opposite sign of x. So this is x minus 3, so I'll take the opposite sign, so the vertex will be at positive 3. And the y value is at negative 1 here, so I'll take the opposite sign, and so we'll see that 3, 1 is where we have our vertex. All right, so then I want to figure out, well, what is the p-value? The p-value is the distance between the focal point and the directrix. I know that since it's pointing up, my directrix will be a horizontal line. And so what I do is I say, oh, well, p is 2 because 4p equal 8. Solve for p, divide by 4, we get p equal 2. So I know that from the vertex over 3 units, up 1 unit, my distance to the p, to the focal point is 2 units. So I just go up 1, 2. So still in the x value of 3, just I'm at 3, 3 now. And then I'm going to go down 2 units, 1, 2, to negative 1 where there's a y. And so my directrix will be here as a horizontal line at y equal negative 1. And now what I need is a couple more points to just help me draw the graph. Now what I do in this case is I try and make this side over here a number that's a perfect square. So I think, okay, what times 8 will make it a perfect square? And the reason I do that is because then that's going to give me a plus or minus of this number here. So, and I can usually figure that out. So I think, okay, well, 8 times 2, well, that's 16 because, you know, it's 2 times 2 is 4. 4 times 4 squared, or 2 squared is 4. 3 squared is 9. 4 squared is 16, and so forth. So I want to find a perfect square. So I know that 8 times 2 is 16. So I go, well, what y value would I need in order to make it a perfect square? So I know that since I'm going up, both the y values will be positive 3, so I can go ahead and put the 3's in for here. Now I think, well, since that's going to be 16, what two values of x make it so that I can get when I square it, so I need a 4 over here, so 4 squared will be 16, right? So what values would make a 2 or a 4 in here? So I go 7 minus 3, oh, that's 4. 4 squared is 16, so I go 7, right? And then I think, okay, well, what else will make a 4 in here to square it? So that's a negative 1. Negative 1 plus negative 3 squared is 16. And so here's my points that I found. 7, 3, right? And then equidistant from the other side. I don't even necessarily need to figure it out. I could do it because parabolas are symmetrical like that. Where if I know that I come over one side 1, 2, 3, 4 units, then I could go 4 units the opposite side, 1, 2, 3, 4, end up at negative 1 and draw my parabola that way. All right, so example number 2, here we go. This time we have y minus 1 squared is equal to 4 times x minus 1. Again, first thing we got to do is diagnose, right? What's happening? We've got a y squared, so that means we're going to either open to the negative side or we'll open to the positive side. And I look at my p-value. Well, this is 4, so that means I'm going to get a positive p, so I'm opening in the positive x direction. And now I find my vertex, right? My vertex x, negative 1, take the opposite sign, that's 1. And take the opposite sign here of the y's, that's positive 1 also. So I know I have a vertex at 1, 1. Set 4p equal to 4, divide by 4, and I'll get p equal 1. All right, so now I know that I have 1 unit away from the vertex, which was over 1, up 1. I'll have a focal point of 1 unit away, and 1 unit behind. In this case now, I will have a vertical directrix, because that's what happens when you get a y squared that opens to the side. You get a vertical directrix. And now again, what I need is some points. So again, I think to myself, well, this is a value that can be squared. So what values of x would I need to keep this a 4? Because 4 is square rootable. So I can say, well, that is, the square root of 4 is 2. So if I can keep this a 1, well, that means that x's values are 2, right? And then what I can do is I can think to myself, all right, well, how would I make this a 2? Because 2 squared is 4, right? So 2 squared is 4. So what minus 1 is 2? So 3 minus 1 is 2. 2 squared is 4. And so then I know it's equidistant. So if I know that there's one spot at 2, 3, then I'll go equidistant, so 1, 2 units, so 2 more units down. I will be at 2, negative 1, and then I'll just draw my parabola there. I've got a focal point at 2, 1, because it's 1 unit inside the bowl for the focal point, and then 1 unit back for the directrix. All right, well, that is graphing parabolas with a shift, right? We've got a vertical shift or a horizontal shift, something to that nature. Anyway, hope you've had a great day. Thanks again. Keep it mathy, and D-Dijkstra out. Peace.